Hi kids, in this video we'll continue with rectilinear figures from ML Aggarwal. We have already done till sum number 12. We'll start from sum number 30. Just look over here. P and Q are points on opposite sides AD and BC of a parallelogram. So first draw the diagram, that is the most important thing. So we'll draw a parallelogram, A, B, C, D. They told P and Q are points on opposite sides AD and BC. So suppose over here you have P, over here you have Q. Such that PQ passes through the point of intersection O of its diagonal AC and BD. So first draw the diagonal AC and BD. Suppose this is O, then PQ passes through O. Show that PQ is bisected at O, which means what we need to prove? To prove PO equals to OQ, then our work is done, which means PQ is bisected at O. Very simple, just look over here. Take these two triangles. Triangle BOQ, triangle BOQ, and triangle DOP. BO equals to OD. We know in a parallelogram the diagonal bisect each other. Okay. Then this angle and this angle are equal, vertically opposite angle, which means angle BOQ. Angle BOQ is equal to DOP. DOP. Why? Vertically opposite angle. Then look over here. This angle and this angle are equal, alternate angle, because these two are parallel and these two are parallel. Which means can I write QBO, angle QBO is equal to PDO. PDO. Why? Alternate angle. Which means these two triangles, see this is equal to this, are congruent, angle side angle, which means triangle BOQ is congruent to triangle DOP, angle side angle, isn't it? And if they are congruent, then the corresponding side will be equal, which means OQ and OP will be equal. OQ is equal to OP, CPCT, which means PQ is bisected at O. PQ is bisected at O. Proved. Clear? Now let us look at the next sum. Now look at 14 part A. Very easy. In the given figure, A, B, C, D is a parallelogram and X is the midpoint of BC, which means we can say CX is equal to BX, since X is the midpoint. Okay. The line AX produced meets DC produced at Q. The parallelogram ABPQ is completed, which means there are two parallelograms ABCD and ABPQ. Prove that triangle ABX, which means this triangle, and triangle QCX, which means this triangle, are congruent, and prove that DC equals to CQ equals to QP. Very easy. First look, in triangle ABX and QCX, whatever, QCX, yeah, QCX. First of all, CX equals to XB, ABX, which means I'll write BX is equal to CX, since X is the midpoint, isn't it? Then this angle and this angle are equal, vertically opposite angle, angle AXB, angle AXB is equal to angle QXC. Why? Vertically opposite angle. Done. So this is equal to this. Now look carefully. This angle and this angle will be equal. Alternate angle, because see, AB is parallel to DP. This BC is a transversal. So this angle and this angle are alternate angle, isn't it? I can write angle ABX is equal to QCX by alternate angle, which means these two triangles are congruent by angle side angle. Look over here, triangle ABX is congruent to triangle QCX. Why? This is angle side angle. Done. Okay, the first part is done. Second part, prove that DC equals to CQ equals to QP. Now these two triangles are congruent, which means, can I write AB equals to CQ, CPCT? Okay, just look over here. AB equals to CQ, CPCT, isn't it? And AB equals to DC also, we know. Why? Because these are opposite sides of the parallelogram ABCD. And AB is equal to QP also. Look over here. AB equals to QP also. Why? Because AB, PQ is a parallelogram. So that's the opposite side. Now combining these three, if you see, AB equals to CQ, and AB equals to DC. So this and this will be equal. Again, AB equals to QP. So these three will be equal, which means, can I write DC equals to CQ equals to QP? Done. Now let us see the next sum. Now look at sum number 14, part B. Very easy. In the figure, point P and Q have been taken on opposite sides AB and CD respectively of a parallelogram ABCD such that AP and CQ are equal. Show that AC and PQ bisect each other, which means basically we need to prove that AO is equal to OC and QO is equal to OP. We need to prove that. Okay, very easy. Show that these two triangles are congruent. Look, this angle and this angle will be equal. See, triangle AOP and COQ and triangle COQ. First thing, this angle and this angle will be equal, which means angle AOP is equal to COQ, vertically opposite angle. Then this angle and this angle will be equal, alternate angle. Okay, angle OAP is equal to OCQ, alternate angle. AP is equal to CQ, given. This was given to us. Okay, which means angle side, which means triangle AOP is congruent to triangle COQ. Why? Angle side. And once these two triangles are equal, the corresponding once these two triangles are congruent, the corresponding part will be equal, which means I can say AO is equal to CO and PO is equal to OQ. This is CPCT, which simply means AC and PQ bisect each other. Done. Now let us see the next sum. Now look at this sum number 15. Very interesting. ABCD is a square, so I'll draw a square first. Look over here. ABCD is a square. A is joined to a point P on BC. So suppose this is a point P. We join A to this. And D is the point. D is joined to a point Q on AB. So suppose this is Q. Join D. Okay. If AP given, AP is equal to DQ, prove that AP and DQ are perpendicular to each other, which means simply if you can prove that this angle or this angle is 90 degree, our work is done. So required to prove is what? DMA, angle DMA or angle DMP is 90 degree. If you can prove this, your work is done. Now look carefully. I'll do this. First of all, look at triangle ADQ. Triangle ADQ and triangle BAP. Okay. First of all, DQ equals to AP. That is given to us, isn't it? AD is equal to AB, sides of the square, isn't it? And this angle is 90 and this angle is 90. Angle DAQ is equal to ABP equals to 90. That is known to us, which means these two triangles are congruent by RHS. See, hypotenuse on one side is equal, so triangle ADQ is congruent to triangle BAP, that's RHS. Like these two triangles are congruent, then the corresponding angle will be equal, which means if you look carefully, this angle and this angle will be same, which means angle ADQ, this is D, okay, angle ADQ is equal to angle BAP, that is CPCT, isn't it? Now once they are proved congruent, just look over here, this entire angle is 90. Angle BAD, angle BAD is 90, isn't it? Now look, this entire angle can be split into two parts, angle BAP plus PAD is equal to 90. Now instead of angle BAP, can I write ADQ plus angle PAD is equal to 90, isn't it? Which means this angle, just look at the diagram, this angle and this angle add to give 90. Now look, in triangle DAM, angle DAM plus ADM plus AMD is equal to 180. That's angle sum property, isn't it? Now look carefully. DAM is nothing but this angle and ADM is nothing but this angle, and these two angles add to give 90. So instead of this I can write 90 plus angle AMD is equal to 180, which means angle AMD equals to 90 degree, which means this is 90 degree. Hence these two AP and DQ are perpendicular to each other, which implies AP and DQ are perpendicular to each other. Done. A nice sum. Now let us look at the next sum. Now look at this sum. Sum number 16. If P and Q are points of trisection of the diagonal BD of a parallelogram ABCD, prove that CQ is parallel to AP. I've drawn the diagram. See, I've taken a parallelogram ABCD and the diagonal BD is trisected by the point PQ, which means BP is equal to PQ equals to QD. Okay, we need to prove that CQ and AP are parallel to each other. Very easy. Just look at these two triangles. Triangle ABP and triangle, this is DQC. Okay, just look. AB is equal to CD, opposite sides of the parallelogram. Angle ABP is equal to angle CDQ, angle CDQ, alternate angle, isn't it? Then BP equals to QD, that's given to us. BP equals to QD. This side is equal to this side. See, side angle side, which means triangle ABP is congruent to triangle CDQ. Why? Side angle side. And once they are congruent, this angle will be equal CBCD. So you can write angle AP, angle APB is equal to angle CQD, angle CQD. Why? CPCD. So they are equal. Now look carefully. This angle and this angle will add to give 180, linear pair. Similarly, this angle and this angle will add to give 180, linear pair. I can write angle AP, angle APB plus APQ is equal to 180. That's linear pair, LP, isn't it? Similarly, I can write DQC plus CQP equals to 180, linear pair. Now I can equate these two. So angle APB plus APQ is equal to DQC plus CQP. Now look, APB, this angle, and DQC, this angle, are equal. We have already done CPCT, which means angle APQ is equal to CQP. So this angle and this angle are equal, which means they are alternate angle. Look carefully, they are alternate angle. And if these two are alternate angle, it clearly means AP parallel to CQ, isn't it? Now let us look at the next sum. Now look at sum number 70. Very interesting. Our transversal cuts two parallel lines at A and B. The two interior angles at A are bisected, and so are the two interior angles at B. The four bisector forms a quadrilateral ACBD. Prove that ACBD is a rectangle. CD is parallel to the original parallel line, which means suppose we have two parallel lines, suppose L and N. These are two parallel lines. There is a transversal, suppose AP. Now angle A, over here there's two angles, they are bisected. Both the angles are bisected, isn't it? At B also the two angles are bisected. Okay, which means if this angle is X, this is X, this is Y, this is Y. If this is suppose small a, this is small a, this is B, and this is B. Okay, prove that ACBD is a rectangle. First of all, you need to prove that is a rectangle, and CD, the line CD which we join, is parallel to L and M. Now very easy, just look over here. 2x plus 2y will be 180, no doubt in that. Linear pair, which means x plus y will be 90. Similarly, 2a plus 2b will be 180. Linear pair, which means a plus b will be 90. Isn't it? Now look carefully. So we have a plus b as 90, which means this angle B is 90, isn't it? In the rectangle ACBD, and x plus y is 90, which means angle A is 90. Very good. Now look carefully. 2x plus 2a will be equal to 180, co-interior. 2x plus 2a equals to 180, which means x plus a equals to 90. Similarly, 2y plus 2b equals to 180. These are co-interior angles, isn't it? Which means y plus b is 90. Now look, in the triangle ADB, x plus a plus angle ADB. Angle ADB is equal to 180, angle sum property, which means this is 90, we know. So angle ADB is 90. So this angle is also 90. Look, we got this angle as 90. ACBD, that quadrilateral, angle A is 90. Angle B is 90. This angle we got 90, which means angle C will be 90, which implies angle ACB will be equal to 360 minus 90 plus 90 plus 90 is 270, which is 90, which means this angle is also 90, which means all the four angles are 90 degree. So in quadrilateral ACBD, we just proved angle A is equal to angle C is equal to angle B is equal to angle D. That is 90 degree. We proved. Now if you can prove that the opposite sides are equal, our work is done. Now look at the triangle ABD. Triangle ABD and ACB. ACB. AB equals to AB. AB equals to AB. That's the common side. Y will be equal to A, alternate angle. See, actually 2y is equal to 2a, which means y will be equal to a. 2y equals to 2a. See, 2y equals to 2a. That's alternate, which means y equals to a, which means angle CAB. Angle CAB is equal to angle ABD. Well, ABD, isn't it? Similarly, 2x equals to 2b. Okay, 2x equals to 2b. So x equals to b, which means angle CBA. Angle CBA is equal to DAB. DAB, which means these two triangles are congruent. Angle, side, angle, isn't it? Which means triangle ACB is congruent to triangle ABD. That's side angle side. Side angle side means this side and this side will be equal, which means, and this side and this side will be equal, which means AD is equal to CB and AC is equal to DB. So the opposite sides are equal and all angles are 90 degree, which means quadrilateral ACBD is a rectangle. No doubt in that. Done. Now the second part. CD is parallel to the original pair of lines, which means CD is parallel to L and M. Look carefully. We'll put O over here. Now, in a rectangle, the diagonals are equal and bisect each other, which means, can I say AO? Just look over here. AO is equal to OD. AO is equal to OD, which means AOD is an isosceles triangle. AOD is an isosceles triangle, which means this side and this side are equal. So this angle, isn't it? And this angle will be equal, isn't it? Okay, so angle OAD is equal to ODA. Okay, side, angle opposite to equal side. Now this angle is equal to this angle, isn't it? DA, suppose this is M, DAM. So instead of OAD, I'll write DAM. So DAM is equal to ODA, which means this angle and this angle are equal, which means they are alternate. And if they are alternate, I mean line L is parallel to DC by alternate angle property. Is it clear? Now let us look at the next sum. Now look at sum number 18. In a parallelogram ABCD, we'll draw the diagram. Diagram is very important. If you get the diagram correct, half your work is done, you know. A, B, C, D. The bisector of angle A meets DC at E. Suppose this is E and A is the bisector, which means if this is X, no doubt this is X. Okay, because A is the bisector, and AB is twice of AD. Prove that BE, which means BE bisects angle B, which means this angle and this angle are equal. We need to prove. And angle AEB is a right angle, so this angle is 90 degree. We need to prove. Very easy. Just look. These two are X because A is a bisector. This angle and this angle will be equal. Alternate angle. Angle EAB is equal to AED. AED is equal to XY. Alternate angle, which means triangle ADE is an isosceles triangle, which means this side and this side will be equal, which means AD will be equal to DE. Okay, now AD is equal to BC, opposite sides of a parallelogram. Okay, one thing they have given, AB is twice of AD. Just look carefully. So AB is equal to, given, see, AD is equal to BC. AB is twice of AD. AB is twice of AD, and AB is equal to DC. Is equal to DC. So DC will be twice of AD, isn't it? Now look, DC, we can write DC as DE plus EC, DE plus EC, AD plus AD, twice AD. Now DE and AD are equal, which means EC and AD will be equal, isn't it? EC will be equal to AD, which simply means E is the midpoint, which means E is the midpoint of DC, and EC is also equal to BC. Why? Because EC and AD are equal, and AD and BC are equal, which means BEC, triangle BEC is an isosceles triangle. And opposite to this, you have this angle. Suppose this is Y. And opposite to this, you have this angle. So they both will be equal, which means angle CBE, angle CBE will be equal to CEB, isn't it? Angle opposite to equal sides are equal. Now look, this angle, okay, this angle and this angle will be equal, alternate. So if this is Y, this is Y. Angle ABE is equal to BEC is equal to Y, alternate angle. So if this is Y, it simply means BE implies BE bisects angle B. Done. Now this angle is 90 degree, you need to prove. Very easy. 2x plus 2y is 180 co-interior, which means x plus y is 90. Suppose this angle is z. Now look, x plus y plus z is 180. Angle sum property, isn't it? Angle sum property in the triangle AEB. X plus y is 90, so 90 plus z is 180, which means z is 90 degree, which implies angle AEB is 90 degree. Done. Now let us look at the next sum. Now look at sum number 19. Very easy. Somewhere very close to the previous sum, you know. ABCD is a parallelogram. So we'll draw a parallelogram ABCD. Bisector of angle A and angle B meets at E. So lies on DC. So this is your point E. Okay, this is your point E, and bisector of angle A and angle B meet at E, which lies on DC. Prove that AB is twice of AD. In the previous sum it was given. Very easy. Look over here. This is X because AE is the bisector of angle AE bisects angle A, which means angle EAB. EAB is equal to EAD. EAD, isn't it? Suppose X. Now this angle and this angle are equal, alternate. So angle EAB is equal to AED. AED is equal to XY, alternate angle, isn't it? So ADE is an isosceles triangle with the two angles are equal, which implies triangle ADE is an isosceles triangle. So opposite to this angle you have this side, opposite to this angle you have this side, which means AD will be equal to DE. Done. Now look at triangle BCE. If this is Y, this is Y. BE bisects angle B, which means angle CBE. CBE is equal to angle EBA. EBA equals to Y. Suppose this angle and this angle will be equal, alternate angle. Angle CEB is equal to angle EBA. EBA equals to Y. That is alternate angle. So this is Y. Now look at triangle BCE. Triangle BCE. These two angles are equal, which means opposite to this side, and opposite to this you have this side. These two sides will be same. Angle BC will be equal to EC. Why? Because it's an isosceles triangle. Am I clear? So this side is equal to this side and this side is equal to this side. And we know, look, AD is equal to BC. These two sides are equal. And AD is equal to DE. And BC is equal to CE. Which means we can say AD in one line will be equal to DE, will be equal to EC, will be equal to BC. Isn't it? We can say like this. Now look carefully. AB is equal to DC. Opposite sides of a parallelogram. Now AB is equal to, instead of DC I can write DE plus EC. So AB equals to, instead of DE, can I write AD? Of course. Instead of EC, I can write BC, and BC is equal to AD. So I can write AD, which means AB is equal to twice AD. Proved. Clear? Now let us look at the next sum. Now look at sum number 20. Very interesting. ABCD is a square. ABCD is a square. The diagonal intersect at O. If P is a point on AB such that AO equals to AP, prove that thrice of POB, which means this angle, is equal to angle AOP. Very easy. Now we know in the square this angle, is 45 degree. So angle OAP, angle OAP is 45 degree. No doubt in that. Okay, this is 45. Now AO is equal to AP. So if this is X, this is also X. Opposite to AO you have this angle, opposite to AP you have this angle. So these angles will be equal. Angle APO is equal to angle AOP is equal to X. Because APO is an isosceles triangle, isn't it? Now X plus 45 equals to 180. So twice X equals to 135. So X equals to 135 by 2. Done. We got the value. Now look carefully. The diagonal bisect at 90 degree in a square, which means angle AOB. Angle AOB is equal to 90 degree. Suppose this is 1. So angle AOB can be written as X plus Y equals to 90. We know the value of X. So 135 by 2 plus Y equals to 90 degree, which is Y equals to 90 minus 135 by 2, which is 180 minus 135 by 2, which is 45 by 2. And clearly, if you divide these two, look over here, y by x, so 45 by 2 divided by 135 by 2. So this is y by x is 1 by 3, so thrice of y equals to x. Thrice of y is which angle? POB. Angle POB is equal to x. X is which angle? AOP. This is what we were supposed to prove. Done. Okay. Now the rest of the sums, 21, 22, 23, they have, I've seen the book, they have actually solved the sum. So I'm not doing those sums. Okay. You try it on your own. Keep it till here in this video. In the next video, we'll look at a new chapter. Till then, take care.